Today, we're diving into what most developers overlook, but what becomes even more important in your career in AI: data governance and active metadata, especially for agentic systems. Gartner predicts that most organizations will fail to get value from AI by 2027 if they don't fix data governance. That means the differentiator for your career is not just knowing how to fine-tune a model, but knowing how to make sure data feeding that model is trusted, documented, and controlled. In this video, you will learn about the concepts required to build self-healing data pipelines, to deliver trusted data faster, and equip businesses to operate more efficiently. If you care about landing a better job or becoming a top 1% data or AI engineer, this is for you. Watch this video till the end to see my interview with Juan Sequeda, Principal Research Scientist at ServiceNow, an expert in data governance, knowledge graphs, and semantic data, where he shares his advice on the topic and where things are going in data engineering. So what exactly do we mean by data governance? It's how we make sure data is accurate, secure, explainable, and used responsibly. For developers, this shows up in very practical ways. Imagine shipping an AI feature trained on messy data. You will spend weeks debugging why it makes bad predictions, only to discover half your records were duplicates or missing values. Or worse, you'll get an urgent message from compliance because personal information slipped into a dataset and now your model is exposing it in responses. Many data governance programs fail. A group of chief data officers and consultants found that people don't understand what data governance is, that organizations rely on technology alone, and that unclear ownership and unrealistic expectations derail progress. If you merely build a data catalog and expect your problems to disappear, you will waste time and money. But if you take governance seriously and build it into your workflows, you will stand out. The foundation of governance is metadata, information about your data's origin, transformations, usage, and meaning. Good metadata is the requirement for any scalable data program. But many companies build giant catalogs and get stuck on what to do next. Often teams are obsessing over cataloging metadata and delaying operational benefits. Instead, teams should stop just capturing metadata and start using it to create business value. This is where active metadata comes in. Instead of storing static tags, you should build systems that continuously collect, update, and analyze metadata. Active metadata includes schemas, business definitions, arrival timestamps, lineage, quality scores, usage patterns, and any other data about your data. Focusing on active metadata allows you to surface problems more proactively, so you can act on it, or your AI agents can act on it. To see why active metadata matters in practice, let's walk through a practical example: a self-healing pipeline. Imagine your company must periodically delete data from states with strict retention rules. You decide to build a batch pipeline that queries tables containing personal information and filters data by state. The naive approach hard-codes table names and column names, and it works until someone renames a column or introduces a new table. And suddenly, the pipeline fails or silently omits data, and engineers scramble to fix it. Now, picture a different design. You build an active knowledge graph that links every dataset to business terms and policies. Instead of writing "select state from table 1, you write "select everything associated with the business term state from any table with that term." At runtime, the pipeline queries the knowledge graph. It finds all the tables that contain sensitive information and haven't been accessed in 6 months. It looks up which columns correspond to the business term state. It retrieves the list of states affected by the retention policy by reading the policy metadata. It constructs queries for every relevant table, selecting the columns associated with the state and filtering rows according to the policy, and repeats this for all identified tables. Because the pipeline parameters come from the knowledge graph, it adapts automatically when a table changes the structure or a new table appears. And if the policy changes to include more states, the query adapts without touching the code. This is what self-healing means. By parameterizing pipeline configuration with business context, you eliminate some of the breakpoints. The knowledge graph needs to be kept up to date, but much of the metadata collection can be automated. Tools that infer data profiles, detect schema drift and anomalies, allocate resources based on performance bottlenecks, and enrich metadata with semantics. Metadata intelligence can suggest which new data sources to integrate, which execution engine to use, enabling self-healing integration jobs and optimal pipeline construction. Building on self-healing example, now let's look at how Agentic AI builds on these ideas throughout the pipeline. Traditional data engineering requires explicit programming at every decision point. If a data source changes format, someone updates the code. If performance degrades, someone investigates. This reactive approach stops scaling. Agentic AI operates differently. It understands pipeline objectives, reasons about trade-offs, and adjusts its behavior to meet these goals. When a source introduces new fields, an agentic system evaluates whether they matter and automatically incorporates them into transformation logic. It balances throughput and cost while enforcing data quality, making decisions that would take human engineers hours or days to evaluate. First, data ingestion. Agentic systems revolutionize ingestion by automatically discovering and evaluating those new data sources. They check if a source aligns with our business goals and data quality requirements and configures the pipeline with the right connection parameters and error handling. When an API changes its format or volume, the agent adjusts ingestion logic on the fly rather than failing and waiting for human intervention. It monitors performance and dynamically tunes parallelization, batching, and retry strategies based on the current load. Next, in data transformation, agents can infer transformation logic from examples, business rules, and downstream usage patterns. Instead of hard-coding every rule, you can provide examples or specifications, and agent can generalize them. When source schemas evolve, the system adapts by updating transformation logic while still keeping it consistent. Then, orchestration and workflow management. Agentic AI changes orchestration from static schedules to dynamic, context-aware execution. This analyzes system load, data freshness requirements, and downstream dependencies to decide when to run each job and how many resources to allocate. It prioritizes workflows that have high business impact and deprioritizes experiments during peak periods. When failures occur, the agent doesn't merely retry. It analyzes failure patterns, identifies root causes, implements the fix, or escalates to a human with rich context if automatic resolution isn't possible. For data quality and observability, autonomous quality monitoring turns reactive debugging into preventive maintenance. Agentic systems learn normal data patterns and detect anomalies without relying on brittle rule sets. They trace issues through complex lineages to pinpoint the transformation or source causing problems and implement fixes or alert teams before downstream reports break. Combined with metadata intelligence, agents use arrival timestamps and schema inference to detect delayed or drifting data, allocate resources to underperforming stages, and recommend new data sources. For metadata management and lineage, agentic systems automatically discover metadata by analyzing schemas, transformation logic, and usage contexts. They learn business terminology and tag data with relevant business context, making it easier for non-technical users to find what they need. Detailed lineage information allows the agent to predict downstream impacts before implementing changes. So this living documentation means your catalog never goes stale. Finally, data delivery and integration. Agents optimize data delivery by analyzing consumption patterns and automatically generating APIs or adjusting storage formats. They monitor usage and change caching or indexing strategies to maintain performance. In some cases, they can even create integration points for new consumers without requiring human intervention. The principles of active metadata and governance apply to any business domain where workflows must adapt to changing conditions. For example, with e-commerce fulfillment, instead of hard-coding warehouse capacity and shipping rules, you could build a knowledge graph that tracks product metadata, inventory levels, shipping constraints, and seasonal demand patterns. When Black Friday traffic spikes unexpectedly, the system automatically detects the anomaly in order volume, cross-references it with historical patterns and current inventory metadata, and then dynamically reroutes orders to less congested fulfillment centers, while adjusting shipping methods to maintain delivery promises. If a regular product category shows unusual return rates, the active metadata system traces the anomaly back through the supply chain, perhaps discovering that a specific supplier batch has quality issues and automatically flags similar inventory for inspection while updating procurement rules. The system continuously learns from these patterns, building richer metadata about supplier performance, seasonal variations, and consumer behavior. So this allows it to be preemptively adjusting workflows before problems cascade. Just as with data pipelines, this approach transforms reactive firefighting into proactive adaptation, where business logic becomes parameterized by living metadata rather than brittle, hard-coded rules. Of course, there are trade-offs. Agentic systems can behave unpredictably if you treat them like a black box. Large language model agents produce inconsistent results, and small prompt changes can lead to different actions. Giving agents control of sensitive operations without oversight is very risky. Even a 5% error rate is unacceptable in regulated industries, and unapproved agents built by employees can expose companies to compliance risks. So to address these concerns, you need to embed observability and human oversight into your agentic systems. Log every decision, enforce policy gates, implement kill switches, and require human approvals for high-risk actions. You can make an agentic system operate not as fully autonomous system, but as an autonomous proposal approved by human system. There are maturity models that show that successful agentic operations can start with full-stack visibility, then progress to alert assistance, then agents acting under supervision with audit trails, and only later to fully adaptive agents. In many cases, the benefits justify the effort. Organizations that adopt Agentic AI report reductions in pipeline maintenance and faster insights from new data sources. Active metadata and knowledge graphs reduce manual data cleaning, accelerate project timelines, and simplify compliance. But these gains only materialize when governance, metadata, and agents are integrated, when there is a strategy, and when people are trained to use them. Remember those key lessons. First, data governance isn't optional or bureaucratic. It's the backbone of trustworthy AI. Many programs fail because they focus on technology and neglect people, process, and ownership. Invest in rich, active metadata and knowledge graphs, but use them to drive automation and self-healing systems rather than building static catalogs. Embrace agentic AI to automate ingestion, transformation, orchestration, and quality monitoring, but build the guardrails and policy enforcement into your agents. Finally, align your governance and agentic initiatives with business objectives and measure their impact so executives see the value. By applying these patterns, you will build data systems that adapt, heal, and scale, and give you a competitive advantage. This can help make you the engineer that companies can't do without. See my interview with Juan Sequeda, Principal Research Scientist at ServiceNow, an expert in data governance, knowledge graphs, and semantic data, where he shares his advice on the topic and where things are going in data engineering. So nice to be here in Sydney at Data and Bytes.
Of course.
How are you enjoying the conference?
I love being at conferences like Data and Bytes because you get the community. This is where the people who are here are the boots on the ground who roll up their sleeves, who know how to who are actually getting things done. I like to go talk to people at the leadership executive level, but this is where the rubber hits the road. So this is where all that stuff gets done. It was really important to be here.
What are you thinking of the top mistakes that you're seeing in the companies that you work with, especially now that data engineering is a core part of what businesses are looking at with AI taking over their strategy? What are the top things that you see people getting wrong?
So it's the first big thing is not focusing on what is the business value, right? And I think this is kind of obvious thing to say, but sometimes we got to restate the obvious over and over again. So a test that I always do with folks, and I come from the data catalog, data governance world, and I ask people, so why do you need a data catalog? And if the answer is, well, because we can't find data. I'm like, I get it. That's a technical problem. But what are you trying to achieve? What is the real-time goal? No, we're trying to be more data-driven. I get it. Everybody in the world trying to what are you trying to do? No, we're trying to democratize. Look, then if I get those answers, those platitudes, I'm like, you're really completely disconnected of what is going to drive business impact. What are the what are the outputs? What are the outcomes? So I think this is that big disconnect we see right now. So it's focusing just on the technical challenges instead of connecting all directly to the business challenges. So I think this happens over and over again, all the time. And so the other thing is that because we're so much now with the hype and we want to go do AI and stuff, so we're building a chatbot because it's the thing to go do. But again, what is the goal? What are you trying to go do? And it's okay if you're trying to go experiment to test this technology out. But at the end of the day, like, you have to be able to say that we're investing in this because it is connected to some particular, very specific business level objective. So to summarize my answer here is, the big fault is that if you are not able to connect as direct as possible the work that you're doing in data and AI to the top level objectives organization. If you don't know why you're doing that work and how that is providing value to the company, then that's a problem. And somebody needs to ask why.
Do you believe that the data engineering roles need to evolve with that shift? One shift is with AI. Another shift is that we do need to understand the business domain closer. And data engineering teams have traditionally been more isolated, like working on platforms and the pipelines. And yes, we see the data in the tables, but there's rarely a direct line to the business stakeholders. So how do you see the data engineer, data architect roles evolving?
So I think it's evolving, or at least it should be evolving, to data and knowledge engineering. So we will still have the needs to be able to manage those the pipelines and the platforms. But I think what's been done implicitly is the business context, the understanding of what does this mean. And I think now it's very clear that for AI, I'm talking about Gen AI and LLMs, is that they need to understand that context, that the business context. What does this stuff mean? So meaning semantics is now becoming very, very it's becoming mission critical. So that's the evolution. Like, that is the next thing that we need to be focusing on. And I think knowledge engineering is not a new thing. Like, this is something that comes from the early AI the other AI way back in the 80s of expert systems. And what we learned at that time is that it was something hard to go do. It was very brittle. It was not scalable. But we got some great new machinery that can help us scale this stuff, especially when it comes to like language and things. So I think now we have the opportunity to actually scale out. Imagine now building out agents or bots or chats, whatever you want to call them, to go talk to people saying, hey, what do you mean by this? What do you mean by this? What do you mean by that? And then we can really scale out the meaning around that. And then we'll figure out, hey, 80% of this thing we have no agreement. We only agree on the 20%. Okay, now we know that. And I think that's the type of stuff that we're able to go fix and start kind of moving the needle forward. We've always had these problems. We just have never been incentivized to go focus on that. And I think a lot of the work that's happened up to now with data in the data engineering in the data engineering world is that there's been so many assumptions made. So I need my data to fit this format I'm being told, and I coded it this way. Okay, that coding that you did, there is some semantics, that implicit meaning, but you could have coded it 10, 15 different ways, and it could have changed depending on the semantics, but you probably didn't even think about, oh, it could have meant this thing, this other thing. And I'm not saying that this is the data engineer's fault or anything. It's just that we just got to do something fast, and that's the first way to go do this, or that was the assumption that was made. And I think now we're realizing we need to make those assumptions explicit. And I think that's the evolution. So the shift from data engineering to data knowledge engineering, this is where the data product managers come in, because they need to go talk to your stakeholders, understand requirements. Really, it's not just about the technical aspects. I think we'll have people who focus on the technical aspects, but we'll have the roles who are going to focus more on the people in the process, and be having those translator roles. And we've been talking about this and doing this for the last 10, 20 years. I think now we are actually incentivized to go do this because of AI. So I think that's the evolution I'm excited about.
Now in AI, we're struggling with how do we encode the intent to action, and semantics and intent are friends.
The word ontology has always been that, don't use that O word. And now people are using this. And this is where I'm like really calling out people to go look at, don't reinvent the wheel. There's already so much standards and so work. So if this is the first time you're looking into semantics, look at things like OWL, like RDF, like these are the open web standards that have existed for 2 decades or more. And guess what? Because they've been out on the web, LLMs, they already know how to go build these ontologies in OWL. And if I'm saying these words and you've never heard about that, this is the opportunity to go learn about that right now.
And I remember those used to be the boring topics, and now all of a sudden they become so relevant. What are your top predictions for 2026?
I think one is, if we look at the market and investment and money, especially how companies are spending their money, right now we're in an era of let 1,000 flowers bloom. So we're seeing what happens. And I predict that very quickly people will say, okay, we got to limit. I'm not going to spend more money. I'm going to use the same money, or reduce my budget or something. I'm going to start focusing on the things I'm already starting to go see value. So I believe, and I really hope, cross my fingers, is that we're going to see the hype kind of come down, and it's a good thing because we're focusing on the on the applications that are actually providing business value. And I think that is going to, I really hope that we're going to go see that quicker. In a way, I will not be surprised if people will see it as, things are kind of collapsing in a way, but it's like, no, people are really focusing. And I think we've learned our lessons in the past, and I really hope, and I'm expecting that we're going to start seeing much more focus. And also because we're letting all those flowers bloom, and they're seeing like that's hard to control. And at the end, I think one of the biggest challenges that I'm seeing is people saying we're going to have agent swamps, all that stuff. So like, how do we control that? Well, it's actually just focusing on the things that are providing value and investing just in those things.
Make sure to like this video and subscribe to the channel. Thanks for watching, and I will see you in the next video. Your reality has changed. You're stuck in your career. You're either using AI or being used. Do you still believe success is guaranteed? You feel it's time to wake up. Old strategies don't work anymore. Welcome to the real world. It will never be the same again. You need to fight for your future. Learn to spot truth from lies. I will help you. Together, we will win.